In this video, we're going to demonstrate some applications for earth leakage clamp meters using the Martindale CM69, which has true RMS measurement, a switchable 50 Hz filter, and a class-leading resolution of 0.001 milliamps, which is just 1 microamp in the lowest range. A common use is for investigating unwanted RCD tripping. As we know, RCDs will operate when there's an imbalance in the currents flowing between line and neutral conductors. Normally, the current that's missing is flowing to earth. So it's important to determine whether this is caused by the accumulation of too many protective conductor currents, as may be caused by filters in electronic control equipment and power supplies, or by current which is leaking to earth unintentionally due to a fault, such as the degradation of cable or equipment insulation. 30 mA RCDs providing additional protection against electric shock can actually operate at much lower levels, even as low as 22 milliamps. So with typical currents of 1.5 to 3 milliamps for some equipment, it is possible for these to add up and cause the RCD to trip. Sometimes as well, appliances may start to produce higher currents, perhaps due to components starting to fail. In residential applications, often a quick chat with the occupier will help to identify a pattern and highlight which appliance may be the possible culprit. But in many cases, it may be more complex with several sources of leakage current. We can check the level of protective conductor currents by placing the CM69 around protective conductors. Here, the earthing conductor gives a reading for the whole installation. As you can see, it's quite high. This is a split load board, so obviously this figure is shared not necessarily equally across the RCDs as well. We can also take readings from individual CPCs to perhaps highlight the circuit where an appliance may be causing a problem. And there's a useful peak function to record the highest leakage currents when powering up remote appliances and equipment. The only problem with readings of protective conductor currents is that by the very nature of parallel earth paths, it's hard to guarantee that none of this current is coming from elsewhere. A better reading then can be made by clamping around the live conductors for a circuit. Any value shown is definitely the difference between what's coming in and what's going out. We can actually use this reading as an indication of the insulation resistance and integrity. So this is a great way to verify insulation resistance without having to isolate the supply. In this application, when making periodic checks and comparing results, it's important to use the 50 Hz filter so that any changes seen are due to changes in the insulation resistance and not other variables like the level of harmonic currents flowing at the time. In this diagram, we can see how in industrial or commercial installations where single conductors are commonly used, it's easy to use this earth leakage test method as a way of tracking down insulation faults and monitoring deterioration of insulation in cables and equipment. We can see how each spur is investigated and how the testing route follows the path of the highest earth leakage reading. We can also use the CM69 to provide an earth leakage test on individual appliances, perhaps because we suspect one of these is the cause of unwanted RCD tripping. It will be necessary to split out the conductors to do this, and here I'm going to use a modified lead. So again, clamping it around line and neutral will provide an indication of the quality of the insulation. Earth leakage testing is an optional test for portable electrical equipment, and there are recommended maximum values for earth leakage current in the IET Code of Practice for in-service inspection and testing, which can be as low as 0.25 milliamps. The low current capability and 0.001 milliamp resolution of the CM69 makes it ideal even for the lowest limits allowed. Another application for the CM69 is the identification and reading of harmonic leakage currents. These can often cause sensitive electronic equipment to malfunction. In addition, some RCDs are more sensitive to leakage currents at harmonic frequencies than at 50 Hz, causing them to trip at lower currents. A common cause of harmonics are electronic control systems, such as those used in variable speed drive controllers, LED lighting, and UPS systems. These can generate harmonics at a range of frequencies leading to distorted waveforms with higher frequency components. To reliably measure and troubleshoot harmonic leakage currents, it's essential to use a true RMS leakage clamp and turn off the 50 Hz low-pass filter so the higher frequencies can be included. Most leakage clamp meters have low-pass filters permanently set at 50 Hz and are not true RMS. This makes them unable to see the higher frequency components or reliably measure distorted waveforms caused by the harmonics. The CM69 is unique in having both true RMS measurement and a switchable 50 Hz filter, making it ideal for both checking leakage current due to insulation breakdown at 50 Hz and leakage current at higher frequencies generated by modern electronics in lighting systems and power supplies. So we've seen how handy an earth leakage clamp meter such as the CM69 can be for fault finding the cause of unwanted RCD tripping and locating troublesome harmonic currents.